Today we are evaluating one-sided limits algebraically and limits at infinity algebraically. So let's remind ourselves how to do this with a graph. As x approaches 2 from the right of h, this is the graph of h here, 2 from the right, what is that limit? 2 from the right is 4. What does that mean? That means as x approaches, and by approaches, that means we're getting very, very, very close to, gets closer and closer to the value of 2 from slightly above 2, higher than 2. So as x approaches 2, from slightly higher than 2, h approaches 4. That's what it means, okay? All right, one-sided limits are pretty obvious when the graph is given, okay? If you had the equation instead, here are some steps. All right, so step 1. Try to do what you do with every limit. Plug in the number for x. If you get a number, then you're done. So yes, we're approaching 3 from the left, but my first step is always just to plug in 3 and see if I get a number. If I plug in 3 here, I get 1 over 27. That is just a number. I am done. If I plug in pi over 3, I get square root of 3 over 2 divided by 1/2 plus 1. I would multiply top and bottom here by 2 and get the square root of 3 over 1 plus 2, which is just the square root of 3 over 3. I am done. I just got a number, right? Most of the time, when you have a one-sided limit, when you're given an equation, you're not going to just get a number like this. Most of the time you're going to get an indeterminate thing. Namely, most of the time you're going to get 0 in the denominator. You're going to get a number on top and 0 in the denominator. And how do we handle that? Okay, if you get a non-zero number in the numerator and a 0 in the denominator, you've got a vertical asymptote. So you need to determine if your answer is infinity or negative infinity. Okay, to do that, we plug in a slightly larger number if it's a right-hand limit and a slightly smaller number if it's a left-hand limit. So for instance, this limit. This is a rational function. It has a vertical asymptote of x equals 3, and we're approaching 3 from the right. So visually speaking, I already know that I've got a vertical asymptote at 3. If I want the right-hand limit, all I need to do is figure out, is this positive infinity or is it negative infinity? Okay? That's the visual thinking behind this. Okay? Vertical asymptote, my answer is either infinity or negative infinity. Those are my options. Okay? All right, here's what we do. So first off, I would just plug in 3 for x. If I just plug in 3 for x, I get negative 2 on top and I get 0 on the bottom. True? So I'm going to rewrite this limit. And I'm going to keep my negative 2 that's on top, but I'm going to go back to my x minus 3 on the bottom. Don't put the 0 down there. Now, I want you to plug in a number that is slightly to the right of 3, like 3.001, 3.001, or 3.0000001. If you plug that in for x down here, yes, it is going to 0, but it is on the right side of 0. It's positive. It's approaching 0, but it's positive. So we've got -2 on top, and we're dividing by a positive number that is very, very small, close to 0. This is -infinity. So it was this one on that graph. Number 4. If we just plug in 4 for x, I'm going to get a -1 from this piece. I'm going to get a 6 from this piece. I'm going to get a 0 from that piece. We have got ourselves a vertical asymptote. There is a vertical asymptote at x equals 4. I'm approaching 4 on the left. Is it positive infinity or is it negative infinity? It's got to be one of those. Okay, so I'm going to approach 4. I'm going to rewrite this limit. On the top we have a -6. On the bottom we still have this x minus 4. Okay? And I'm going to plug in a value that's close to 4 but on the left of 4. Close to 4 but on the left of 4. Like 3.999. If I plug that in, it's approaching 0, but it's going to be negative. It's approaching 0, but it's negative. And -6 divided by a negative is going to be positive infinity. This is positive infinity. Okay, that's the thought process on those. Let's do this one. We're approaching 2 on the right. 2 on the right. This will be a 2. This will be a 9. This will be a 3. This will be a 0. 0 on the bottom, number on top, vertical asymptote. Vertical asymptote when x is 2. We're approaching 2 on the right. Are we going up or are we going down? Well, we can find out. I'm going to rewrite my limit, putting numbers where I can. I could reduce that further, but there's no need to, because I'm approaching 0 right there, right? So I know my answer is going to be positive or negative infinity. Okay. I'm approaching 2, but on the right of 2, slightly higher than 2. So 2.001. If I put that in for this x, yes, it's going to 0, but this is going to be negative. And I've got a positive divided by a negative. That is a negative infinity. Okay? If I put a 5 in for x, 25 minus 30 plus 8. 25 minus 30 plus 8 is positive, right? On the bottom, 2 times 25 is 50, minus 45 minus 50, that's a 0 on the bottom. Took me a second, but I figured out that there's a number on top and a 0 on the bottom. So I'm going to factor this first. I'm going to factor this first. Up on top, I'm going to have x minus 4, x minus 2. On the bottom, 2x and x, 5 and 1, minus and plus. Alrighty. So I'm going to put 5 back in. If I put 5 back in, I have a 1 from this piece. I've got a 3 from here. I've got 11 from here. I'm just putting in 5, and I've got a 0 from that, right? So this limit is 3 on top 11 times x minus 5 on the bottom. And now we're going to plug in something approaching 5, but on the left of 5. That would be like 4.999. If I put that in here, yes, it is going to 0, but it will be negative. I've got a positive divided by a negative. That's a negative. Negative infinity. Okay? If you get 0 on top and on bottom, then you've got a whole, and you will be doing what we did yesterday with, or the last time, with just factoring and reducing, multiplying top and bottom by a conjugate, or by a number to get rid of a complex fraction. Okay. Those are our techniques for that. Okay? Alrighty. For limits when x is going to infinity, or negative infinity, we only need to examine the highest powered term in the numerator and the highest powered term in the denominator. Okay? We've already done this last semester, so I'm just going to do this quickly. We did this when we did rational functions. So this is the same thing as the limit as x approaches infinity of 4x cubed over 5x cubed. The x cubes reduce out, and we get 4 over 5. I'd like to take this opportunity to show you the algebra behind why we get to just ignore these. Why do we get to just ignore these? Let me rewrite this. Why do we get to just do that? I'm going to multiply here top and bottom by 1 over x cubed. If I multiply top and bottom by 1 over x cubed, 4x cubed times 1 over x cubed is 4. 2x squared over x cubed is negative 2 over x. X over x cubed is x over x squared. Is 1 over x squared. 19 times 1 over x cubed is 19 over x cubed. On the bottom, we have a 5 plus 7 over x squared minus 22 over x cubed. Now x is going to infinity. X is going to infinity. This piece is going to 0. This piece is going to 0. This piece is going to 0. 0, 0. We are left with 4 over 5, which is what we got up here. This is why it works, you guys. Okay? Alright, number 7. As soon as I see that x is going to infinity or negative infinity, I know all I have to do is find the highest powered term on top and the highest powered term on the bottom. Make sure you keep any coefficients that are with it. And I'm going to rewrite the limit only using those. As long as I'm writing x's, I'm writing limit. Don't forget that. Now I'm going to reduce the x's. This reduces to x squared on top, right? So this is equal to negative 2x squared over 7. Now we let x go to negative infinity. Negative infinity squared is positive infinity, right? Times a negative 2, though. That makes it negative infinity divided by a positive negative infinity. Okay? This is one of the reasons why I don't like the rhyme that some of you may have learned in the past. the top no, bottom O, same co rhyme. The reason I don't like it is because the no is too non-descriptive. I need you to tell me if that's a positive or a negative infinity. Okay? This way will always work. Always. So just do it this way. Alright, number 8. X is going to infinity. So I'm going to find my highest powered term on top and the highest powered term on the bottom. I'm going to rewrite my limit. X to the 5th over 7x squared. 7x to the 6th, sorry. Okay. I'm going to reduce my x's. That reduces to 1 over x, right? So x in the bottom. So this is equal to this limit, 1 over 7x. Now we let x go to infinity. We'll have a very, very large unbounded number. Multiplying by 7 will not change that. 1 divided by that, this is 0. Okay, one more. X is going to negative infinity. Highest powered term on top, highest powered term on the bottom. We have x to the 5th over 3x to the 4th. Our x's reduce to x over 1. So this is x over 3. Now we let x go to negative infinity. Divided by 3, this is negative infinity. Okay, and that's how you evaluate limits where x is going to positive infinity or negative infinity with an equation. I think that's it for today. Next time we're together, we're going to talk about continuity. So I'm about to do this video.